Good morning guys and welcome to part 2 of circles. Today we will be moving forward with a few more theorems in the circles chapter, and again if you are having any doubts regarding the content of this chapter, you know where to mail me and ask me for any clarifications. Now, so far we have learned about the equality of the chords, the arc and the angle subtended at the center. Now we move on to the next theorem. This is one of the most important theorems in this circles chapter, and this is applied to many other chapters of grade 10 also. I mean geometry chapters of grade 10 when you are proving something with regard to circles. Okay. So the theorem is the perpendicular from the center of a circle to a chord bisects the chord. So let me write down the theorem, and then we will break the theorem into its part and see the proof of the theorem and also the converse of the theorem, which is obviously the next theorem that we will have to study in this chapter. So let us see what exactly this particular theorem means. The perpendicular from the center of a circle to a chord. So which means that you have a circle with a center, obviously. You have a chord. You can draw the chord however you want to. For ease of it, I will be drawing something like this so that there is a visual easiness when you are doing the proof. Now, perpendicular from the center of a circle to a chord. So there is a line which is at 90 degree. So that is the first part. The perpendicular from the center of a circle to a chord. What happens to the chord? It bisects the chord, which means that this side will be equal to this side. That is our proof. That is what we need to prove. We need to prove that this line and this line, or this two line segments, both are equal in length. So let us start with the proof. And as I told you, the circles chapter, most of the proofs are based on the congruence of triangles. So we will need to make a particular construction because there is no triangle, as you can see. And again I told you, the first the construction that comes to your mind is to create the radius. So let us create the radius over here. I will be joining these 2 points. I will be naming the chord as AB, and this particular point where the perpendicular drops, let it be P. Okay. So what is given to you? You are given a circle with center C. Okay. You also know PC, or let us say CP. CP is perpendicular to AB, which is the chord of the circle. Okay. What was the construction that we made? We joined A to C. Construction was join A and C, also B and C. Now, do you have triangles over here? We do have triangles, and how will we prove they are congruent? It's very easy. AC and BC are the radii. PC is a common side, and this angle is at 90 degree. So which congruence will be applied over here? We will be applying RHS congruence, right angle, hypotenuse and the common side. Okay. So I can say that these two triangles are congruent. Therefore, AP is equal to BP. The reason being corresponding parts of congruent triangles. So let us write it down once so that you get a better clarity about the proof. As you can see, I have written down the proof of the congruence over here. It is very easy. You can write it down by yourself and then cross verify. So we have proved the theorem. Now I told you that whenever there is a theorem in geometry, the converse of the theorem we need to see whether it is applicable or not, and unfortunately most of the times it is applicable. And so what happens is that we need to prove the converse of the theorem. We need to learn the statement as well as do the proof of the theorem. So let us see what is the converse of the theorem. The theorem states that there is a perpendicular from the center to a chord and it bisects the chord. So how will we state the converse of the theorem? If there is a line through the center of a circle which is bisecting a chord, that line has to be perpendicular to the chord. So in the converse of the theorem, we have a line segment that is bisecting a chord. We need to prove that it is perpendicular to the chord. Okay. So now let us do the proof of the converse of the theorem. It is again by congruence. You can please try it out by your own and then cross verify. Let us see the proof of this theorem. So what is given to you? A circle with a center C is given to you, and what is the other data that is given to you? It is given that this particular line is bisecting the chord. So PA is equal to PB. I have not even changed the diagram. The diagram is exactly the same. But in this case, we need to prove that angle APC is equal to 90 degree and angle BPC is also equal to 90 degree. I have not written what is to be proved. Okay. So for the construction, I am, again drawing the radius. So joining AC and BC. So I have written over here. So let me explain how to prove this given theorem, and then you can look at the statements that I have written down. So in this particular triangle, you know that PA is equal to PB. AC is equal to BC because they are the radius of the same circle. Okay. And you can also say that PC is equal to PC. The reason being it is the same line, so congruent to itself. So these two triangles are congruent by SSS congruence. Okay. Now, can you find out another congruence for this two particular triangles? We can do it that also. PA is equal to PB. CA is equal to CB. You can also say that this angle and this angle are also equal. The reason being they are the base angles of the isosceles triangle ACB. ACB is an isosceles triangle because these two sides are equal. So for an isosceles triangle, you know that the base angles are equal. So if this angle is x, this angle is also x. So I can say that this angle and this angle are equal. So these two triangles are congruent also by SAS congruence. So whichever one you want to take, you can take and continue with the proof. We have proved that the triangles are congruent. Since the triangles are congruent, what can you say about the corresponding angles? They are equal. So I can say that this particular angle and this particular angle are equal because they are corresponding parts of these two congruent triangles. But the sum of these two angles is 180 degree because they form a linear pair. Now the sum of two angles is 180 degree, both the angles are equal, so each angle has to be 90 degree. So this is 90 and this is 90. So CP is perpendicular to AB. Okay, I have written down the statement, but I have written down the statement for SAS congruence. You can do SSS or SAS according to your convenience and then proceed with the remaining part of the theorem. So guys, now we have done two theorems. One was there is a circle and there is a perpendicular from the center of the circle to a given chord. It bisects the chord and the converse of it. Now, what is the main result that you are getting from these two theorems? See, whenever you are doing a theorem and then you are doing the converse, there are always small results that come from this, any of the theorems in geometry that you do. Most of them will not be mentioned, directly in the textbook or anything, but you are supposed to deduce it. Okay. So let us see what is the first, first outcome of these two theorems. Here I have drawn a circle. I have taken a chord AB with the center C. Then you know that AO is equal to BO and CO is perpendicular to AB. That is our theorem. And then the converse of it. If this line from the center is bisecting this chord, it has to be perpendicular. So we saw that. Now let us see what is the result that we are getting. If there is a line which is bisecting a chord and is perpendicular to it, it has to pass through the center. That is the main thing that we are getting from these two theorems. So it will why is it useful? It will actually help us in determining the center of a circle when it is not given to you. A very rare case when center of a circle is always given to you. But if a question comes as to how do you locate the center of a circle when the center is not given to you specifically, is by using this particular theorem. Any chord you are taking in the circle, and if you are drawing the perpendicular bisector of it, perpendicular bisector means 90 degree, dividing it into two equal parts, this line will inevitably pass through the center. It is a must. Okay. So how do you locate the center of a circle when the center is not given to you? You know that there is a chord. You are drawing the perpendicular bisector. It will pass through the center, which means that center can lie in any of this part of this, any part of this particular line. Sorry, my bad. Okay. Now, where is the center? Actually, how do we locate the center? Suppose we are taking another chord. If you draw the perpendicular bisector, that also will pass through the center. Two lines can meet only at one point. Since the two lines has to pass through the center and they will meet only at one point or intersect only at one point, that point has to be our center. Clear? Two lines or any number of chords you are drawing, if you draw the perpendicular bisector, it will inevitably pass through the center. For locating the position of a chord, how many lines do you need? You need only two lines or two chords of a circle. Draw the perpendicular bisector so that both of them will pass through the center. So you have an intersecting point. Okay. So that is one of the main results that we are getting from these two theorems. There is a question in exercise 10.3 of the NCERT textbook. It is, suppose you are given a circle, how will you locate the center? So I just explained it now, but then how will you write the steps of that particular question? So suppose you are given a circle, so it is a construction sum basically, so they expect you to do the construction also. So again, it is dependent on your teacher. If ma'am says or the sir says, it is totally a theoretical question. You need to write only the theory part of it, or if you are asking, to construct also, you know what to do. You will draw a random circle of any radius. You will draw two random chords, however you like. It can be this way or any random chords, and you will draw the perpendicular bisector. And I hope you know how to draw the perpendicular bisector of a line. It is grade 7 constructions. So when you draw, this will pass through a common point. Okay. Now, how will you write down the theoretical part of it? Let us see. So, you will basically draw any two chords of the circle, then you will construct the perpendicular bisector of the chord, and then they will meet at a common point. So, as a reasoning, you need to write the theorem, the perpendicular from the center of a circle to a chord bisects a chord and its converse. So, from these two theorems, it follows that the perpendicular to a chord, perpendicular bisector to a chord of a circle will pass through the center. And any two lines will have a single meeting point. So the two perpendicular bisectors has to intersect at the center. Okay. So you have to give a proper explanation whenever you are doing the proof for a geometry sum. Okay. So now let us move on to the next theorem, which is not a theorem that is given in the NCERT textbook, but it is an additional theorem from the concept that we have just done. Okay. So this is the next one that we need to prove. Prove that the perpendicular bisectors of two chords of a circle meet at the center. That is what we did right now from those two theorems. But then they are asking you to prove this also. Okay, instead of deducing it from those two theorems. So let us see how we can do this. So when we are having a sum like this, please ensure that whenever you are drawing a diagram as a proof in geometry, try to draw a slightly bigger diagram. Now, if it is a sum that you already know really well, you can manage with a smaller diagram, a cramped diagram also. But if it is a sum that you don't know, always try to space it. So, it is more clear as to what we are looking at and in what we need to prove. So, whenever you are drawing two chords, unless they say the chords are intersecting, try to space the chords. Intersecting chords and then joining it up to the center, it becomes a little kind of a, a messed up diagram. So, I will take two chords which are not intersecting. This is my center. What do we need to prove? We need to prove that the perpendicular bisectors meet at the center. So let me assume that the perpendicular bisectors are not meeting at the center. So this is a point of bisection. That will not change, right? So this is my perpendicular bisector and this is my perpendicular bisector. Let them meet at another point O dash. Okay. Now the point where the line is getting bisected will not change in spite of the center changing or not. This point will not change. A line can get bisected only at one point, right? We already know the theorem. The perpendicular from the center of a chord to a circle bisects the chord. So there is another line which is perpendicular to the center of the chord, which is bisecting the chord. Same with here also. Okay. So now I have written down the statement. ON and O dash N are the perpendicular bisectors of CD. Okay. O dash M and OM are the perpendicular bisectors of AB. Now a line can have how many perpendicular bisectors? It can have only one perpendicular bisector. So O dash M and OM has to be the same line. And O dash N and ON also has to be the same line. So since two lines can intersect at how many points? It can intersect only at one point. Since O dash M, suppose it is like this, and OM are on the same line, and O dash N and ON are on the same line, and both are intersecting at exactly only one point, O dash and O has to be the same point. So, the perpendicular bisectors of two chords or how many ever chords are there in the circle, it can intersect only at one point, which is the center of the circle. The parts of a straight line intercepted between two concentric circles are equal. So, this is a sum that I have taken from a different reference book. The same sum is given in the NCERT book in a different form. It is exercise 10.4 question number 4, which says that if there is a line that intersects two concentric circles, you like A, B, C, D and all is given to you. You have to prove that AB is equal to CD. Please go and refer the textbook for the exact question. Now, the only new term that you have to understand from this particular question is concentric circles. Concentric circles are circles, any number of circles having the same center and different radius. Okay, so all the circles with the same center, they are all called as concentric circles. Fine. Now, intercepted basically means in between. So, what they are asking you to prove is that there are two concentric circles and there is a straight line like this. The part of the straight line intercepted between two, this part is equal to this part. Okay, now let us start with the proof of the question. Now, before you listen to what I am doing as a proof, I want you to figure it out on your own. I will explain two methods of doing it. You can follow whichever method you want. Either you can use the latest theorem that you have done, or you can use basic congruence to prove the same. Okay, so let us see both the methods and see which is more convenient for you and you know how to apply them. So, here I have drawn the diagram. We need to prove that AB is equal to CD. That is a part of the line that is intercepted. If you look at the NCERT book, clearly they have given to you as to what to prove. Okay, so let us see the first method. O is the center of the circle. If I am dropping a perpendicular to the chord, please mention it under the construction part of it. What can you say about the smaller circle? BC is a chord and OP is perpendicular to BC. I can say that BP is equal to CP because perpendicular from the center of a circle to a chord bisects the chord. So, BP is equal to CP. Forget this smaller circle was not there. I have only the bigger circle and a center, and AD is our chord. What can you say? AP is equal to DP. So, same reason. Okay, perpendicular from the center of a circle to a chord. Now, this complete line is equal, this part is equal to this part. So, what can I say about the remaining part? When I am subtracting AP minus BP, what do I get? This is AP and this is BP, I will get AB. This is equal to DP minus CP, or this is equal to CD. So, I can say that AB is equal to CD. Here we have used the latest theorem which we have done on the circles, and 2 steps, 3 steps, the sum will get over. Now, let us look at the basic method or the layman's method in order to do this particular sum, which is by using congruence. But I suggest you personally to use this particular method because it's an easier method. Second, your teacher will expect you to use this particular method because this is a new theorem that you have studied for this particular year. But anyway, let us go to the congruence method and see. Suppose you are not able to get this method during the exam, you can definitely get through congruence. Congruence has to come from triangle, so I will join up the radius. This is the radius of the smaller circle and this is radius of the bigger circle. Now, this smaller triangle, what can you say? You can say that this side is equal to this side. Radii of the smaller triangle. In the bigger triangle, OA is equal to OD. The same reason, radii of the bigger triangle, a bigger circle, and OB is equal to OC, radii of the smaller circle. Okay. Now we need one more side or one more angle. Now, can I take one more side? I cannot take AB is equal to CD because that we need to prove. So, can I take the angles? You know that this angle is equal to this particular angle because they are the base angles of the isosceles triangle OAD. So, I can say this angle is equal to this angle. But again, that is not enough because it is not an included angle. We have only this side and this side. I need this angle or I need one more angle. What can you say about this angle of the smaller triangle? They are equal because they are the base angles of the isosceles triangle OBC. Correct. Now, angle B is equal to angle C. So, this angle is 180 minus angle B. The reason being it's a linear pair. Similarly, this angle is 180 minus angle C. Again, it is a linear pair. So, in this outside triangle, I have this angle equal. I have this angle equal, I have this side equal, I have this side equal. So in order to prove the congruence of this triangle and this triangle, I can use any congruence that I want other than S congruence, because the third side is something that you need to prove. I can use SAS congruence or ASA congruence. ASA congruence, you know how to. SAS congruence, how will I use? The included angle. These two angles are equal to these two angles in this triangle. So the third angle also has to be equal. So you can use SAS congruence also. So both the triangles are congruent, and therefore the third side, they are equal by means of CPCT. Now it is left to you as to which method you are using. Definitely try to stick to the new method that we have learned, but during the examination, if you are not able to figure out which method to use, or you are not able to get the theorem in circles, please go for congruence. I told you most of the theorems or proofs in this particular chapter can be done through congruence. If two circles intersect at 2 points, prove that their centers lie on the perpendicular bisector of common chord. Okay, so here I have not written down bisector, so perpendicular bisector of the common chord. So what do we need to prove? We need to prove that you have two circles which are intersecting at 2 points. If two circles always intersect at 2 points, we have not done that theorem yet, but we will come to the theorem after this. So AB is the common chord of both the circles. So A is a point here, B is a point here. We need to prove that this chord has a perpendicular bisector, and this perpendicular bisector, it's a line, should contain the centers of the two circles. So does it contain the centers or not is what we need to prove. Now this is supposed to be one of the tougher sums of this particular chapter. And this particular sum, most of the time, whenever I am checking the reference book, or to be very frank, even when I was teaching the students, we were always using the method of showing that the line joining the centers, which is O dash, the line joining the centers is a perpendicular bisector of the common chord. Now, that is a proof that you should follow, and or even use it for your examination if that is the proof that is being taught in your school. The reason being that you all need to write exams, and losing mark is not a very pleasant thing. So if you feel that that particular proof is that the proof that I am giving, the optional proof that I am giving is more tedious than the proof that is being followed in your classroom, or if you feel that you need to show it to your teacher first in order to get more clarity on the proof, please do so before attempting it for the examination. Okay, so now I will explain to you both the methods of doing this particular sum, and then I want you to understand both the methods and see the logic behind both of the methods. Okay guys, so now you have two circles and you have a common chord AB. Now O and O dash are the centers. So let me mark O and O dash over here. This is our first center O, and this is the second center O dash. I am taking X, Y, Z as the perpendicular bisector of AB. I am not telling that O and O dash is lying on the line or not lying on the line. I am just saying that X, Z, Y is a perpendicular bisector. Okay. Now, this particular angle is 90 degree because XZY is a perpendicular bisector. So, XZ is perpendicular to AB and YZ is perpendicular to AB. So far is the detail that we know. Now, let us see what we can find out from this. O and O dash are the centers. So, since Z is a point of bisection, it will not change for a line. There is only one point of where you can bisect the line. So, if I am drawing a line from O to Z is a point where it is bisected, right? So, if it should be at a 90 degree angle to AB. The reason being, the line from the center to a chord which will bisect the chord is at 90, is perpendicular to the chord. It's a converse of the theorem. So, OZ has to be perpendicular to AB. Similarly, O dash Z also has to be perpendicular to AB. So, I have got OZ is perpendicular to AB and O dash Z is perpendicular to AB. We know that OZ then will become the perpendicular bisector of AB, and O dash Z also will become the perpendicular bisector of AB. Since a line can have only one perpendicular bisector, XZY is already the perpendicular bisector. Therefore, OZ and O dash Z are, with OZ and O dash Z, O and O dash are 2 points that should lie along XZ and YZ. OZ and O dash Z has to lie along XZY, or you can say it in a better way that OZ has to lie along XZ and O dash Z has to lie along YZ. Therefore, O and O dash will lie on the perpendicular bisector of the common chord. So this is a relatively simpler proof, and as I told you, please recheck it with your teacher if the proof is okay before you decide to move on with the proof. Now let us do the proof that is very commonly taught in all the classes, I guess, and we can find it in all the reference book. Okay, so here I have written down the proof as I have explained. So first I have written down what is given to you: two circles with centers O and O dash which are intersecting at A and B. Then we need to prove that O and O dash, which are the centers, lie on the perpendicular bisector of AB. Okay, now construction what we have given is, let x, z, y be the perpendicular bisector of AB. So we have just taken a perpendicular bisector of AB. We need to prove that O and O dash will lie on x, z, y. Okay, so for proof, you know that x, z is perpendicular to AB, y, z is perpendicular to AB, O, z is perpendicular to AB because the line from the center bisecting a chord is perpendicular to the chord. Similarly with O dash z. So O, z and O dash z actually become the perpendicular bisectors. Since a line can have only one perpendicular bisector, OZ and O dash Z, and XZ and YZ are the perpendicular bisectors, OZ and O dash Z has to lie on this particular line. So we have proved as to what is asked in the question. Now I have written this so that you can write it down and you can really understand the proof, and before you want to present it to your teacher. But if you feel that this particular proof is something that you don't want to deal with, still I want you to go through the proof and understand the proof before you decide to stick on with the second proof. Okay, so now let us move on to the second proof. So here we move on to the second proof. So here what we are basically going to prove is that we are going to prove that O dash, which is the line joining the centers, is perpendicular to the common chord. Okay, so let us see how we can do it. So okay, so this is the line joining the common chord, and this is the diagram that we are getting. Now this is joined, okay, and this is also joined. Now, okay, so now we move on to the second proof. In this case, what we are going to prove is that we are going to prove that O dash is perpendicular to the common chord AB. Okay, so now let us see how we can prove that. We are going to do it by basic congruence. If I need to prove O dash is the perpendicular bisector of AB, I need to show that this angle is 90 degree and AZ is equal to BZ. Fine. O dash is dividing AB at an angle of 90 degree at the point Z as AZ is equal to BZ, and also angle OZA is equal to angle OZB. That is what we need to prove. Now let us see what basic congruence we can apply over here. In order to show that this side is equal to this side, we just need to prove two triangles are congruent. So which two triangles you will take? You will take this particular triangle and this particular triangle. Are they congruent? You can see that OA is equal to OB, radius of the same circle. OZ is a common side. But then we do not have a third side because that is what we need to prove. We do not have any angles also in order to show the equality. So we cannot take a third side, which means that we need at least one angle. We cannot take this angle also because that also we need to prove it is equal to 90 degree. Is there a chance of taking this angle or these two angles? It is easier to take these two angles because you can see that these two angles are very difficult to show that they are equal. So let us take these two angles to be, let us prove that they are equal. So we will start with that proof first and then move on to the congruence of these two triangles. Now how will we show these two angles are equal? In order to show these two angles are equal, we need to take two other triangles and show that they are congruent. That includes these angles. So which are other two triangles that you can take? Triangle AOO dash and triangle BOO dash has these two angles. We will check whether these two triangles are congruent. So you can see here that OA is equal to OB, radius of the smaller circle or the first circle. O dash A is equal to O dash B, radius of the bigger circle. O dash is a common side for this triangle and this triangle. So the two triangles are congruent by SSS congruence. Because they are congruent, I can say that angle AOZ and angle BOZ, or you can say angle AO dash and angle BO dash. Let me write it in that way. They are corresponding parts of congruent triangles and they are equal. So this angle is equal to this angle. So when I am taking these two triangles, which is, this is the first part. Now in the second part, we are going to prove the congruence of triangle AOZ and triangle BOZ. I can say that OA is equal to OB, radius OZ is a common side, common, and AOZ is equal to BOZ, which we have already proved from 1. So these two triangles are congruent by which congruence? They are congruent by SAS congruence, side angle side congruence. Because these two triangles are congruent, what can I say about the corresponding sides? I can say that they are equal. So I can say that AZ is equal to BZ. CPCT. So the first part of our proof is over. Now the second part is that we need to prove that this is a 90 degree. We know that angle AZO and angle BZO, which is this angle and this angle, they are equal, corresponding parts of congruent triangles. But the sum of this is a 180 degree because this is a linear pair. So each angle is 90 degree. Fine. Similarly, if this is 90 degree, this is also a 90 degree. Vertically opposite angles, or in very simple words, you can write, after proving this is 90 and this is 90, you can say, similarly, for the triangles A is at O dash and B is at O dash is at becomes a perpendicular bisector for the line AB. Because it's the same proof for these two triangles also, so you can write similarly. Okay, so I will explain once again what we have done in this. We have proved that we have actually done the proof to show that O dash, the line joining the centers, is a perpendicular bisector of AB. Fine. In order to do that, we wanted to prove the congruence of these two smaller triangles because we needed to show that this side and this side are equal. But then we had a problem because though we had the sides, we did not have any angle at all. So first we needed to show that the angles are equal. In order to show that, we took the bigger triangle AO dash and BO dash. And then we proved they are congruent, and then we showed that this angle and this small angle are equal. After taking out the bigger triangles to show the equality of angles, we took out the smaller triangles over here in order to show that these two triangles are congruent. After showing they are congruent, we showed that AZ and BZ are equal because of CPCT. First part is over, bisection is over. Now it is a perpendicular bisection that we needed to prove. So this angle and this angle are equal, again CPCT, but the sum is 180, so each angle is a 90 degree. Similarly, O dash is also the perpendicular bisector of AB. So O dash is the perpendicular bisector of AB. Okay. So this is the second proof, or this is a proof that will be, you can see everywhere as I told you. So please, again I am telling you, recheck and then continue with the proof that you are comfortable with. Okay. So now let us do some sums which has got some numerical values. Too many theorems, you should take a break whenever you are doing too many theorems. Try to mix it with a few sums which do not include only proof but a few calculations also, so that you do not get mentally tired of geometry. Okay. So now let us do a few sums which incorporate these theorems, and you can find the values of some chord, some distance of the chord from the center, etc. etc. They are pretty easy. So the first one is the radius of a circle is 13 centimeters and the length of the chord is 10 centimeter. So you have a circle with center O whose radius is 13 and there is a chord which is of 10 centimeters in length. Now this is 13 and this is 10. Find the distance of the chord from the center. Whenever we are asked to find the distance, it is always the perpendicular distance. So from the center we draw a perpendicular. Okay. Now you know that the chord is totally 10 but it will be bisected. This is 5 and this is 5. Now what triangle do you have here? Right angle triangle whose one side is 13 and the other side is 5. You need to find this. Please apply Pythagoras theorem and get the value. I am not even going to do it because it is too simple. I will move on to the next. In the figure, O is the center of the circle of radius 5 cm. OP is perpendicular to AB, OK is perpendicular to CD, etc. etc. So we need to find the measure of PQ. PQ is the length of the line segment in between the chords AB and CD. AB and CD are given to be parallel chords as well. Okay, so these are parallel chords. The diagram is already given to you. Okay, this is perpendicular and this is also perpendicular. So whenever you see a diagram like this, immediately the theorem, the perpendicular from the center of a circle to a chord bisects the chord, comes to your mind. The radius of the circle is given to you. So if I am joining, this is 5, this is also 5. Fine. Okay. Now AB is 6 centimeters. When AB is 6 centimeters, I know that PB will be 3 centimeters. Fine. CD is 8 centimeters. So I know that QD will be 4 centimeters. Now POD. Sorry. POB. It is a right angle triangle. This is 3 and this is 5. So what can you say about this side? It is Pythagoras theorem again. 25 minus 9, which I will give 16. The root of 16 is a 4. So I can say that OP is equal to 4. Okay. Now let us take the triangle QOD, which is a triangle like this. This is 5. Right? And we know the measure of QD is 4. So what can you say about the measure of OQ? It is 25 minus 16, which is again 3. Because this is a 90 degree, it's a right angle triangle. So I know that OQ is equal to 3 centimeters. OP is 4 and OQ is 3. So what is PQ? It is OP minus OQ, which is 1 centimeter. Okay, it is again a very simple application of the previous theorem itself. It is just that two chords are given to you. So we have found out the measure of PQ. Now let us see if there are any confusing sums in this particular concept. Now let us see this sum. AB and CD are two chords of a circle such that AB is 6 and CD is 12. They are parallel and the distance is given to you. Find the radius. Now this is a slightly different form of the previous sum that we did. You know, just the data that is given to you has been altered a little. So the diagram is this. CD is 12 centimeter. O is the center. AB is drawn. And it is said that the distance between them is 3 centimeters. Because the lines are parallel, at any point which we are taking, the distance between them will be the same. So if it is 3 here, it is 3 here, it is 3 here. Wherever you are taking, it is 3. And we are always talking about the perpendicular distance. So if this is the center and if we draw a perpendicular to CD and we extend this line, that line will be perpendicular to AB also. You know that the perpendicular from the center of a circle to a chord will bisect the chord. So if CD is 12, I can say that this is 6 centimeters. And if AB is 6, I can say that this is 3 centimeters. Okay. Now, it is given that the distance between them is 3 centimeters. Fine. I need to find the radius. This is my radius. This is also my radius. I will mark the radius as R. Okay. Now, let us see how we can find out the value of R from the data that is given to us. You can see that there are two right angle triangles. One is QOB and the other is QOD. Okay. From the triangle QOB, I know that hypotenuse square, which is the radius, is equal to base square plus altitude square. The base is 3 centimeters. Altitude is the length of OQ. OQ is basically OP plus PQ. PQ is the distance between the lines, which is already given by 3. OP, the length we do not know. So we retain it as OP itself. OP plus OQ. So OQ square becomes OP plus 3 the whole square. Now we take the second right triangle, which is OPD. In that also hypotenuse square, which is R square, is equal to base square plus altitude square. Altitude is OP. Clear? So now we have got two equations and we have got two unknowns. So let us see how we can do it. You know that R square is OP square plus 36, correct? So OP square plus 36. Here also I have got an R square. So I will substitute OP square plus 36 in this equation where there is R square. So putting R square is equal to OP square plus 36 in the first equation, I will get I will open the bracket and I will solve for OP. So I have solved for the value of OP. I have opened the bracket. I have equated these two first and then I have opened the bracket using a plus b the whole square. I can see that OP square is common over here. So I cancelled it and then I have got 18 is equal to 6 into OP. So OP is equal to 3 centimeters. Because OP is equal to 3 centimeters, I have substituted it in the second equation and I will get R square is equal to 45 or R is equal to 3 root 5. Now, if they give you the value of root 5, multiply it and find out the decimal value. Otherwise, you can leave it at 3 root 5 centimeters. I hope it is clear to you. It is the same concept except that we had two unknowns over here. So, we had to form two equations and substitute and find out. Okay. So, let us see what we have done in class today. The first is the theorem, the perpendicular bisector from the center of a circle to a chord bisects a chord. Then we did the converse of the theorem. We did both the proof by using congruent triangles. Now we did the perpendicular bisector of a chord always pass through the center. That was a result that we deduced from the first two theorems. Then we learned how to locate the center to draw the perpendicular bisector of two chords and it will inevitably pass through the center. Now we proved how the perpendicular bisectors of two chords will always meet at the center and not at any other point. We took an arbitrary point O dash and then we showed that O and O dash has to be the or along the same line or they have to be the same point basically. Sorry. And then we learned that a length of a line intercepted between two concentric circles, they have to be equal. We did two proofs for that. One was by congruence and other was by using our theorem that we studied today. Then we did the sum regarding the perpendicular bisector and the common chord. I gave you two proof and the proof that I gave, please recheck with your teacher. I told you. So please do that before you proceed with that or you proceed with the other proof. Okay, and now then we did a few sums regarding all of these theorems and stuff. Now we will end this particular video with one sum under this concept, common chord and the perpendicular bisector. It is a numerical sum, so we have to find a particular value and then we will wind up the class. If you are having any doubts in this video, mail me. I will always be there to answer your questions. So let us have a look at this question. Two circles of radii 10 and 8 centimeters intersect and the length of the common chord is 12 centimeters. Find the distance between their centers. So we have two circles whose centers are O and O dash and AB is a common chord. We need to find the length O dash. AB is a common chord. We know that the line joining the centers is perpendicular to the common chord. So the common chord is 12 centimeters means this part is 6 centimeters and this part is 6 centimeters. Okay. We also know that this point, okay, let us call it as P and this as Q. We know that O dash P is equal to 10 centimeter because it is a radius of the bigger circle and O Q is equal to 4 centimeters. I am sorry, 8 centimeters. Okay. And we also know that this particular point, let us denote it by X. AX is equal to BX is equal to 6 centimeters. Fine. And there is a 90-degree angle over here. So I have redrawn the diagram into a slightly bigger diagram because it was getting all cramped up. So here you can see that I have joined OA and OB. OA becomes our radius of the smaller one. So it is 8 and this is also 8. Now look at this triangle. It's a 90-degree triangle. This is 6 and the hypotenuse is 8. So I can find the value of OX over here. So OX square is equal to 64 minus 36. Oh, sorry. I need to find the value of OX over here. Fine. Similarly, if I am joining this one, I know this length is equal to 10 centimeters and this is 6. So I can find the value of O dash X. And when I am adding OX and O dash X, I will get the distance between the centers. So let us see what value we are getting. So after solving, I am getting the value of OX as 2 root 7 and the value of O dash X as 8 centimeters. Because there is a radical involved over here, let us assume that they will give you the value of root 7. So you can multiply and get a decimal value and you can add up this and this. Okay. So the part 2 of circles is, I am like stopping it for the time being. It has been a pretty long video, I guess. And so till I post the next video, please go through the concept that I have already explained to you. Meanwhile, if you have any reference book in your hand, or if you can go online and check for additional sums, please do that, and please understand the concept, before you proceed with, looking into the answers and then trying to by heart the proof and all those things. Try it on your own. If your exams are coming up, well, you don't have any other option. But if you are not appearing for any examination right now and you are in the process of only studying this particular chapter, please take your time to do the proof on your own. And if you are having any doubt regarding your proof, you can always email me with the proof that you are doing, so that I will go through the proof and get back to you.